question is actually, I think, very complex algebra. So what you need to do is, you have this expression and you want to show it's the solution of this. Of course, you need a velocity and acceleration, so you diff it twice, and you need product rule, so you just need to be careful here. I mean, if you're careful, you can avoid making any mistakes from my perspective, I think. Where's my cursor? So after that, we plug it into the dE, and we equate right hand side and left hand side, and then we need to use these conditions, right? It says if, so we just show we can use them to plug into this to make the coefficients equate. We use this, we use this, here we use them, and then we can equate the coefficient and get to LHS equal to RHS. Also, we need to check initial condition for differential equation, because there are a lot of differential equations that fit this dE due to plus C restriction. But after you diff it, this disappears. After you diff this, it becomes 0. So you need to check, not only see if the dE works, that is the thing after you differentiate works, but we also need to check if the initial conditions work, not the thing after you differentiated it. So you need to check the initial condition. And let's look at question 2. Actually, I think question 2 is where things becomes a bit more interesting and fun. These two questions, I love them. They're very fun. So xr equal is the displacement of the object at r's time, that is at rest. So if it's at rest, as we know in simple harmonic motion, then it must have maximum velocity. So here is at rest, here is at rest, here is at rest, here is at rest, here is at rest. So we just need to find the stationary point, and the way we do it, we diff it and we equate to 0, and then we can solve this. We can solve t using this expression. It's just trig equation. Then we need to sub it back to get the actual distance here. So after we plug it back, we need to manipulate the trig identity. So it's here. Then here we use compound angle. So let's move to next page. We use compound angle, and finally we get the condition that we want. Very good. Now for marker. It's a very interesting question, and let's go. So the standard method, you know, a common mistake people make, even ChatGPT sometimes makes the mistake, is that when you have an xt graph, and you want to find the distance, the standard way is you find the turning points, that is the stationary points, and you add the distance. So you do not need integration. You don't need integration. You can't integrate every time you see, because it's an xt graph, it's an xt graph. It's already distance, and it doesn't make sense if you integrate distance with respect to time. So let's go. It's, if we want to know the total distance, it's this plus this plus this plus this. See, it's this, etc. And of course we need absolute value, because it's distance, it's not displacement. It's an infinite series, and we can use the result we have here. We can generalize it. So after each step, the only like infinite series we can use, you can expect is a GP. It's always geometric series or arithmetic series, but it's too easy, so they won't use it. It's the most common thing we can use is GP. And do you know this? Can you do this? No, you can't. It's out of syllabus, but you can do this. It's in syllabus, and it's the only infinite series you can have. That's the only one you need to know and you can expect. So you use this infinite series for GP and you simplify it, and you get this very weird stuff. And when I got to this step, I was thinking, damn, I must have made a mistake, right? Because there's no way you have this complex result and you have this alpha equal to this. But it turns out that it is this stuff, because I checked every step. It's very elegant, it's very correct, and there's no logic problems, and this is math. If it's right, then it's right, and this is what the sample answer says. And the last thing you need to say, that it is dependent on, so you can find out that it's actually dependent on k over n, but it's asking you to show that it's dependent on p over q. It's dependent on p over q. So how would you? So now you need to prove k over n is actually dependent on p over q. So as we proved, d is dependent on k over n, and we just need to prove that k over n is dependent on p over q. Then we can prove that d is actually dependent on p over q. So it is actually very, they said you just need to show that it is dependent only on. They didn't ask you for what's the function. Why did they not ask that? Because it's too complex. You simply can't do it. It's such a complex question. You can only know their determinant. You can't know exactly how they determine it. And you just plug in the definition here to show this is dependent on this, and this is just some easy algebra to separate this as the variable. You need to show this as the variable, and you just need to divide q in the denominator and the numerator, and you can just show. So you show that k over n is dependent on p over q, then it's the distance is only dependent on p over q. It is a very beautiful question. So what have it assessed? Mechanics, obviously, in integration and SHM. It also assessed trig equation. Although it's not very hard, it still assessed it. It also assessed GP series. It also assessed, that's probably all. And I would say it's just your courage. Although the last question is a 4 marker and it seems weird, complicated expression, you must trust your logic. That you can actually do it. So no need to worry. You can do it. And if you want to have a further look, just look in the link below the description.